I think a few more to join. We'll wait for another minute and we'll start.
సార్ ఒకసారి సారీ టు డిస్టర్బ్ ఒకసారి మాట్లాడొచ్చా? హలో
Okay, let me confirm. Hope I'm audible as well. If it is visible to everybody. Have the session. Okay, we have discussed this topic and the specific slide on first class. We'll jump into the another topic. Yep, which is the utility hazards and controls. So with respect to, if we talk about the utility, we'll talk about water, we'll talk about air, power, and thermic fluids. Thermic fluids in the sense of hot oil, etc. Fuel, steam and heating media, brain cooling media, inert gas, purging media, etc. All these are comes under utilities. I also need attention for the safety point of view, and their failure creates an immediate danger which requires similar immediate controls. Okay. I'm unable to see the continued class after 30 minutes of class ID automatically ends the session. Yes, it is basically it is 45 minutes session. Accordingly, it will automatically log off actually. Better to use Microsoft Teams. It is not my decision. I'm sorry. It is up to the institution. And I'm just like a guest lecture. You can talk to the consent team. Okay. And I'm sorry. I can't help you on that. Yeah. Yeah. Okay. Thanks. So as I mentioned, utilities or the various mediums which will involve in this process, as we see here, the water, air, thermic fluids, steam, brain, chilled water, the normal water, inert gases or compressed air, everything, the purging medium like nitrogen, everything comes under this utility division. So those are the backbone for the entire the chemical plants or the operations or the process. Because if you want to do a reaction, if you need a heat, so the utility comes in. Either you use a steam or hot oil or hot water or other any heating medium. And if you want to stop that reaction, you need to have a cooling system. Again, the chilled water or cold or brain comes in. So this is how the utility is the major plays a major or crucial role in a chemical manufacturing process. If it is fails, what will happen? As we have discussed in our previous lectures also, we should make sure that our cooling systems are working properly. We have to cross-check every often to know the condition of the system. So, for example, you're doing a chemical reaction, maybe for n number of reasons, the reaction went to an exothermic state. So there you have uncontrollable heat. So there you have to stop the stirring or heating application. Then you have to apply the cooling system. If your cooling system fails, what will happen? the reaction goes worse, then it may rupture the vessel, either a reactor, either a other kind of the vessel or equipment you're using for that specific reaction. So the utility systems are very crucial than our process equipments as per me, as my personal this thing. So we should give a very good attention on those systems as well. So therefore, the compressors or condensers, emergency services, standby equipments, etc., should be ready for immediate usage. So we should not given a second opinion that okay, let's see once any problem comes in, we can check it. No, so it is also a primary response, or they're also very crucial, so that we should have good eye on those equipments. Then hazards of such utilities are not only because of their sudden failure, but also due to their working parameters like pressure, temperature, the flow, leakage, and dripping, toxicity, flammability, and also the hazards of vessels, piping, equipment, and instruments through which they pass. It is not about their failure. The failure is the one portion of the hazards of utilities, and the other portion is about the parameters, in the sense the nature of the specific utility. So if you see about the parameters of facility, I mean utilities, they work on certain pressures. So they have in temperature, their speed of flow in case of leakage, dripping, all this also dangerous or hazardous or not welcome things to happen. An uncontrolled process or fire water may corrode the things, and the air pressure can burst the vessel or throw the dust, and also thermic fluid leakage can cause a fire and explosion, and the inert gas diminishes the oxygen level. Diminishes in the sense that it will reduce the oxygen levels in the vicinity for the breathing, and also electric power or steam has already caused many accidents, and refrigerant gases, freon causes the ozone depletion, and thousands of tons of hydrocarbons and carbon dioxide emitted by the fuel combustion pollute the environment. The noise and vibration due to the high flow of steam or air, and other health hazards due to misuse of air, as well as water and steam, electricity, and nitrogen, also the not uncommon things. So those are many hazards in and around the utilities. So we have to so cautious while handling with these systems and equipments. We should have proper inspection, auditing, then verification mechanism around the systems. And if you see in the distillation column, the condenser, when cooling the water, stops due to the heat rise, pressure increases, and also bursts the condenser. So condenser column, what will happen? If the cooling system stops, what will happen? Automatically, the temperature rises, automatically resulting in indirect proportion, the pressure also increases, the condenser gets failure, the vessel itself, it will burst. And the pressure relief devices on such vessels, condensers, and also even on receivers are therefore necessary. So high pressure temperature alarms interlocked with the heat source to cut off the heat supply at the predetermined pressure and temperatures can work as a safety devices. So this condensers also we should run on a certain temperatures. We should have the alert system. So to notify the operator saying that it is exceeded the desired levels or the parameters, so that the operator can alert. And also once it exceeds the designed temperature or the desired temperature, so it has to immediately activate the cooling system so that we can safeguard the system. For the quick cooling water supply, standby pump motor section, also it uses it for the overhead water tank to get the static heavily, and also necessary. It's required. We have to install the pump systems to supply the cooling system to reduce the temperature. And if there is a common motor for reservoir for the process and the fire water both, and such suction pipe of the fire water pump should be deeper than the process water pump to allow the reservoir stop of fire water for emergency. So sometimes what will happen, they won't keep it to the full depth of the reservoir. Generally, it is not happens. It is in the worst case, or if it is any old case of system. So if we have two pumps, so the deeper this one should be for the at least for the fire. Maybe this can be for the process water. If you assume this is a water reservoir, this is what we are trying to explain. Mm, 1 second. Mm, Yeah, now we'll see what are the different kinds of the hazards with the and also the controls. The chemical industry discharges solid liquids and gaseous waste as a result of manufacturing process. So this is about the process related pollution from the chemical manufacturing or chemical industries. Such waste may be a toxic, flammable, corrosive or radioactive, and non-biodegradable or hazardous in nature. And also if it is not properly treated, it pollutes the land, water, air, and overall environment. Yes, Chandramati, just give me a second. I'll admit. Yeah, now you can unmute and talk.
Regarding you were saying that the utility and fire water tank, so I think you didn't complete. Are you going to explain again or?
No, I've completed that. So basically what is happening here, we are talking about, let me come back to the previous slide. So generally it is in a common water reservoir for the process and the fire water both. The suction pipe for the fire water pump should be deeper than the process water pump to allow the reservoir stop for the fire water for emergency. It is mean to say that if you have a common reservoir for your process water as well as firefighting, the firefighting suction should be deeper than the process water. That is what. Now these are the old systems actually nowadays. Most of the times.
There are repeated problems I encountered during my work area. So this setup, I come across one clarity. So the fire water tank, the pipe which is surfacing the fire water tank should be the deeper, right? So the utility pipe section should be at the top level. That's what you are trying to say?
Yes.
Yeah. So if I am having 2K liter for the utility, so how that one thing I'm not able to understand that concept. Suppose I need to suggest for some developer, the setup I need to understand. So I think you can explain.
For example, if you are assuming this is your water tank, so from the
that is 5K. Just imagine it is 5K. There are multiple tanks of
you can take it 5K. But if you see, I am mentioning about a common water reservoir. So I have only one reservoir for my process. So this is my process. I can have one more, which is I can say for utility. And I have one more suction from the same reservoir. I'll say fire.
Okay.
So in such case, wherever I put my fire suction, it should be deeper than these two suctions. That is what I'm trying to say.
Okay, so when I'm utility, So at what level it stops? So at the utility level only it will stop, right? So the rest of the water will be reserved for the fire.
Correct.
So I can utilize, for example, 1,000 liter for utilities, less to 4K, I can utilize for the fire tank, right?
Correct.
So now there will be two different pump, or one single pump will be serving this.
Sorry?
One single pump only will be serving this requirement, right?
For all the three sections you're talking about?
Yes.
No, it should be separate section, I mean pumps for all the three sections.
Okay.
Yeah, the reservoir is common, but the pumps are different.
The reservoir will be common. The pumps
Yeah.
will be
So
different.
again,
Okay.
yeah, again you have to check that what is your approval for the fire water reservoir. So the fire water reservoir, they'll say 1 lakh KL or 2 lakh
Based on
KL
the
or 50
building height.
KL. Yeah, that
Yeah,
also
based on
you
the
have
building height, yeah,
based on
that
the
I have a
building
concern. Yeah.
height, the size of the
Yeah.
building, the category
Yes.
of the process you are in.
Yes.
So all these things comes in.
Okay. Thank you,
Yeah.
sir.
Okay, thanks. Okay, good. There is a one more. How many types of hazards? So there are n number of types of hazards. I can say physical, chemical, biological. There are different types of hazards we had done in Jones. Yeah. Yeah. So with respect to the pollution, so we are talking about the emissions, which will happen through our chemical manufacturing process. There are different types of emissions. There is maybe a toxic or flammable in nature, as well as corrosive or radioactive, and non-biodegradable, and also the hazardous in nature as well. Those can be treated in, and also it pollutes the land, water, air, and overall environment. If at all you want to see, so you can if you're already in working professional, you can understand the different kinds of waste, and also you'll have the process emissions limitations also in your CFO or CTO, concern for operation, or in some places in India they call us consent to operate. So you can check there your process emissions also, they have limitations which is given by PCB from state level or central level. So the water, soil, land, and air pollution create many problems and need efficient control. And effluent treatment plants and also appropriate scrubbers, exhaust, and flare, incineration, and other neutralizing or inactivating devices are most desirable, and they must work for all working hours or in effective manner. So all the appropriate scrubber, as you mentioned, it is in a diluting system, which is connected to the process vessels. Whatever the leakages or the process emissions, those will be routed through the scrubbers. Here we'll have a diluting medium. Basically, mostly they use hypo solution to dilute the process emissions. Then instrumentation for safe plant operations, they use multiple types of instruments to monitor the parameters and to control the various situations. Now, to understand the various types of chemical hazards in foregoing parts, we should know the instruments and the equipments we need to install in our process to control. To main control, measure, and alarm, record the process parameters, various industrial instruments or in safety devices are used. And we'll see what exactly they are. You see here, anemometer, which is an instrument we use for the speed of the wind and also other moving gases. and atomometer, which is an evaporometer, an instrument measuring for the rate of evaporation rate of the water, and barometer for measuring atmospheric pressure, and barograph, which is used in the methodology for recording the paper, the variations in the atmospheric pressure, and we can see an hydrometer for measuring density and also relative density of the liquids, and a manometer for measuring the gauges parameters, etc. And gas and fume detectors and alarm systems for the gas leakage warning instruments. So this is an electronic instruments having a sensor and also the audible alarm to give a warning when the preset air gas, which is toxic or explosive mixture, exceeds the TLB. So these detectors work on the set limit. Basically, it is above TLB, threshold limit value. As we all know, the threshold limit value is calculated for the 8 hours of work duration. Then if it is an explosive, they'll be set on LEL or UL limit. So it detects the flue gases or LPG, smoke, petrol, vapors, and also paraffins, fumes, hydrocarbons, ammonia, freon, hexene, acetone, etc., etc. All these can be detected by the various detectors. And the metal detector, it detects the metallic objects of the ferrous and non-ferrous materials hidden in the pockets or bags, etc., and can allocate the cancellated conducts. Then electronic flashers, built-in solid state electronic flashes, which can be a flash mains, the bulb, and also service lamps to maintain the adjustable flashing rate. It can use for the danger indicator and also attracting the attention. So that these flashes are for the emergency communication purposes. Then flame-proof equipments. So switch gears and lighting fittings, cable conductors and cable grounds and accessories, switch sockets and limit switches, rotary camp operator switches, isolators, fuse units. It is all about all kinds of the electrical fittings should be a flame proof. If you see a flame proof or explosion proof electric motors are type D and type E, increased safety, and type M, non-sparking, and type P, which is pressurized or selected for the all hazardous area. Just a second, guys, 1 minute, please. Then process control instruments for temperature, thermocouples and radiation pyrometers and optical pyrometers and resistant thermometers. And for the pressure strain gauges or pressure transducers or pressure gauges, and high vacuum measurements, bottom gauges or bellows gauges or diaphragm gauges, etc. To be frank, this we need to have a practical idea, and we have to see all these gauges. Then only we can understand exact functionality of the equipment. But with respect to the course point of view, this is not so important. Just for your understanding only. For the level, we have level gauges or detectors and float gauges, mercury manometers. Then for the flow, we'll have liquid field manometers or float type manometers. For the quality analyzers, commercial automatic analyzers. Then for centralized, we have digital computers and automatic petroleum processing controls. Okay. Then instrument. Instead of providing elaborate or complex instrument system, the hazard should be reduced, and hazard operability study should be conducted to assess the potential hazards and operating difficulties as well. And the measurement should be a direct variable and at the direct location. And while designing the alarm and other factors like instrument failure and operator confidence, his information should load or should be considered. And as far as possible, the instrument design should be as fail safe. So once you put an instrument, if it is fails also, it should be in a safe manner. So safe manner in the sense, even my brake fails, also my vehicle should go and stop properly. Such a way we have to design. A range of instrument should be sufficient so that even low input can be measured. Range in the sense, this is also a crucial parameter actually. We have to understand this is very important during the calibration of our tools or other things also. For example, if we take in a pressure gauge or temperature gauge, or if you see in a pressure gauge or PSI or bar, for example, if it is in PSI or if it is in a bar, so it has to be tested on the instrument or the pressure gauge which is made for or which is using for. They should not check, for example, it is represented in bar, you should not check in PSI. If they are doing like that, they should provide the conversion factors in your calibration certificate. It is simple that how you are measuring, how you are on what unit you are measuring by using that instrument, it should be calibrated on the same units. They should not calibrate on other units and they should not give the calibration certificate. It is not valid. We don't know how they have calculated what the conversion factors they have taken the reference. We have to ensure. Then control should be taken, and even range. The range also very important. So you have made for your set up your pressure gauge for from 2 to 10 kg, but your system also goes down beyond 2 also. In such a case also we have to consider the lowest the what you call range. It can go from such level, you have to have an instrument. In case of failure of the auto controls, and manual control should be also provided for the safety. So this is vice versa. We should also have the auto controls then and also have manual controls in case auto controls fail. So I should use the manual control to protect the system. Then fault finding instrument should not be disturbed by the fault itself, and service instruments for air, power, inert gas, and should have high integrity. Instrument should be checked regularly and also repaired quickly. Then instrument design should be such that it should indicate its fault easily. So the instrument should also indicate in case of its fails or it is faulty, it should be able to give or trigger an alarm to the respective operators. And the process operators also should be trained to find the faults of the instruments, and test should be corresponded as nearly as possible to expected plant conditions. It may be past workshop test. The valves may be stick to the jam, and also jamming in the open position is dangerous, and more positive isolation may be required, and double block and bleed valves. So these double block and bleed valves will help us really for taking maintenance of such critical pipelines. And human errors should be fully considered, and ergonomic principles should be applied to reduce the human errors, etc. Okay. Then safety aspects of instruments. So instrument may be failed due to the functional fault or loss of containment from the instrument. It is the one chance. Then the slight the glasses or rotometers made of glass can crack or leak the fluid which is inside, and if leaks or dangerous glass should be avoided. Then material of construction should be proper, and after considering the properties of the material to be handled or working parameters, the material for instrument should be selected. So some of the MOCs, the material of construction of the specific instrument which is not compatible with the material which is handling, then there is no use. So we have to check the MOC of the instrument also before a purchase. So the pressure transmitters and also the regulators can damaged by the overpressure. If you check the brake, their pressure should be safely released, and the protection against the corrosive fluid. Necessary use of inert liquids in impulse lines on pressure transmitters or chemical diaphragm seals on the pressure gauges. The sampling and impulse lines should be checked for the blockage, and steam tracing is useful against the freezing. So if it is in a freezing cold temperature goes, then we can use the steam to clear the clog or the blockage. And the thermowell to hold the thermometer should be carefully designed to care into the account of corrosion or erosion. Pulse stating the flow in a flow meter can cause incautious or design or orifice plate should consider in this factor. So if you see an orifice plate, I think we have seen already in last class. It is similar like it is opens. It will just open. It is an orifice plate which is installed in the pipeline. Then this is connected to the dump tank. So it is also an emergency device. In case of any emergency, if the safety relay valve which is not activated, so this orifice will help us to release the reaction material into the dump tank. And complex instruments like analyzers and speed controllers, vibration monitors, and solid weighters are generally less reliable. The consequence of failure should be carefully analyzed, and out of different types of pressure regulators like PRVs, pressure relief valve, NRVs, non-return valve, and NFVs. This I have to check. I'm not able to recall. SE is a safety valve, and RD is the rupture disc. Okay, I'm